All right, welcome to Jstz, everyone. This is a presentation on Jstz. So it's written Jstz, pronounced Jstz, and it's called Justice for All because we are all going to dive into Jstz, which is a native JavaScript environment for Web3 development. So who am I? My name is Arthur Breitman. I'm the co-founder of Tezos, and as you'll see, Jstz is a part of Tezos. So what is it exactly? So we have Tezos, a blockchain that launched in 2018, also known as the Tezos Layer 1. And on top of Tezos, a few applications have been built in the form of rollups, or smart rollups, as we like to call them. The first one being Etherlink. So Etherlink is live now. It's available. It's essentially a fully EVM-compatible Layer 2 built on top of Tezos, and we have quite a few EVM dApps launched on it. And much like Etherlink, Jstz is a smart rollup. It's an L2, so it's built on top of Tezos L1. And what's special about it is that it can run JavaScript natively. And that might sound familiar, but we're going to go into what that means specifically. That means in particular no compilation, no extra language needed to interact or deploy with applications. You're doing all in JavaScript. You can use all standard tools, all standard APIs, all standard libraries. So first, why JavaScript? If you look at the origin of Tezos L1 and the languages on Tezos L1, it's a very different approach. Initially, Tezos focuses on a very, very domain-specific virtual machine called Michelson, which is great for making formal proofs about your program, being very careful, and checking your types. I think it's great for a very high-value financial application. But we see a lot more things today in the world of crypto and Web3. We are seeing games. We're seeing a lot of experimentation. And there's a whole universe of JavaScript developers out there who haven't yet wet their feet into the technology. So we would like to give them a very familiar environment. So yes, it's the most popular programming language by usage. There are millions of developers around the world. There are advanced IDEs, debugging capabilities, testing framework, deployment pipelines. So whatever you think of JavaScript as a language, whatever flaws it might have, you have to weigh this against the massive amount of infrastructure that exists around it. Very rich library ecosystem. And the thing that really started me getting a lot of interest in supporting JavaScript natively back in 2021 was looking at how large language models were becoming better and better coders. In 2021, you had just GitHub Copilot. Now, of course, it's much more common for people to be using large language models for code development. And the thing is, well, they're reason, but they're also very much trained on data from the internet. And most of that data is going to be in JavaScript and Python. Now, they're smart. They can do, they're very good at translation. So what they learn in one language, they can learn it into another language. But you still have some degradation. And so if you test the performance in code writing, you will find that the more samples you have of a programming language in your training data sets, the better your performance. And so you should expect the performance in JavaScript and Python, where there's huge corpuses, to, at least for a while, exceed the performance in other languages. So I find this AI connection to be quite interesting in strategically choosing languages. Okay, but hasn't JavaScript been done before? So many people have talked about JavaScript. I think one of the first one pitching this was, I think it was a blockchain Lisk, and then you realize that they basically had a governance procedure for every single smart contract. You had to basically get it approved by voting. They didn't actually support it. So I named a few here. Of course, Jstz, which I'm talking about today. JSLego, which is a programming language available for Tezos L1. Gorek, which is a great project. Using ideas from object capabilities in JavaScript, and also Near has had experiments with JavaScript. And there's different approaches, but I think what distinguishes Jstz is that it really is JavaScript, right? It's the off-the-shelf native JS runtime. You can run V8, essentially. JSLego, it was a transpilation, so we would use the syntax of JavaScript to run this on L1. You still have to understand the VM. You still have to understand really the underlying Michelson. So you could use similar syntax, not the tooling. Agoric, fantastic product, super interesting ideas. But again, this is not exactly vanilla JavaScript that you are using. You have to kind of like buy into the whole framework. Near also had an approach with compilation to assembly script, and I think using QuickJS. So it's a subset, right? Doesn't support everything. It is kind of like JavaScript, but if you're a traditional JavaScript developer and you try it, you will find the edges very quickly. So in contrast, with Jstz, what we're doing is we are using off-the-shelf native JS runtime. We follow the latest ECMAScript specifications and the WinterTC compliance API. And it's integrated directly in Tezos L1 with EVM compatibility. I will also touch on that. In terms of developer experience, I would say one of the defining characteristic of working on Jstz as a product was trying to make the development as much as possible like web development. And that means, for example, that when contracts call each other, they follow an HTTP syntax. So why? Because, well, it's familiar, but also it lets you leverage a lot of libraries which are out there in the JavaScript ecosystem. So if you had to put a tagline on the DevX aspect of Jstz, it's think like a web developer. How would you build a dApp? How would you build a smart contract if you were thinking like a web developer? So we're trying to replicate this web development experience from the ground up. A standard HTTP request response pattern, as I've mentioned, so that's how contracts talk to each other. We also have traditional like serverless JavaScript pattern for writing smart contracts. And interestingly, and that goes beyond DevX, a support for asynchronous calls. That's not something you see in blockchains typically. So typically what you will see is contract calls another contract, calls another contract, calls another contract. You have a whole atomic operation. You can't really wait. You can't say, oh, I'm going to do an operation. I'm going to wait for some results. Maybe the result is coming from an oracle. Maybe there's some slower process and I don't need my answer right away. You can do it, but it's clunky. It's not written typically in a native language where you have to do this. You'll have to say, well, I'll explicitly create a callback entry point and I'll have some other contract call me. Here, your contracts can have a lifespan across a transaction that is going to go, I don't want to say across multiple blocks because there's actually no blocks in Jstz per se, just transactions, but you can have a long lifespan to a transaction. So what do we include? So first of all, it's available via NPM, so you can install it like you would install any normal dev tool. You can use your favorite NPM libraries, including but not limited to validating payload, making HTTP requests, generating ideas. You can bundle your dependency directly into the deploy app. You could deploy just like you would with Node.js through a CLI that we've built. All the popular testing framework work outside of the box. And you can integrate with standard dev tools, any dev tool that implements a V8 inspector protocol, like the Chrome console, for example. So really, it's not just like, oh, look, here's a proof of concept, you can do JavaScript. No, we went all out and said it has to be exactly the same as developing a normal JavaScript project. And that is what's being achieved with Jstz. I also think of Jstz not just as the rollup itself, but as something a little bigger. And I like to say it comes with batteries included. Batteries included means, yes, you have the chain, you have the kernel, you have all this logic, but really when you're building in an environment as a developer, you don't really care about what is part of the kernel, what is another service offered by some other party. You want a simple, bundled experience where you have all the tools that you need, everything that you could want. And that is what I call the batteries included aspect. So one of it is Oracle services. There's many, services that offer oracles today. You could be using Jedlink, Redstone, all of those, and you still need an integration. And to be honest, if you are on the side of foundations these days or any other project, you know that a lot of the business model of these services is essentially a payment, like very large payments for integration. It is quite expensive. That's their business model. No shade, but it gets really expensive. So what you want instead is you want this built in. I'm the developer. I want a good Oracle service. I want it to work. And so enshrining it into the protocol, getting a protocol which by default is going to give you the service. Is it part of the kernel? Does it run with a TEE? As a developer, you might care about the security aspect of it, like can I actually trust it? But beyond that, you just want it to be available. You want it to be part of the standard library. You want it to be part of your standard experience, and that is what we offer. So it's easy to use. It's based on a TEE, so it can give you. It can follow the approach, for example, of the town crier to give you like off-chain APIs. So any HTTP APIs, exchange prices, all of that good stuff included native to the chain. What else do we have? Native account abstraction. It's a big topic. Lack of standardization, lack of support in the protocol are limiting a lot what people can do with account abstraction. So it's supported at the protocol level, giving things like social login, biometric login. Again, you do this with trusted execution environments, recovery without seed phrase, progressive security. Now, again, none of this is unique. You'll have, yeah, there are services, there are vendors, there are wallets that offer all this stuff. But as a developer, that's a very fragmented experience. You have to kind of like go and get your pieces there. I think there's a standard business idea that everything is bundling or unbundling, and this is very much about bundling. Let's bundle the best of what is available today for developers. Let's take the best part of it, a selected part of it, and give it one experience on Jstz. So it goes way beyond JavaScript. It's really about replicating not just the language, but the experience of building in an environment where you just have everything at your fingertips. Sponsored operation, of course, gasless operation, that's a big deal. If you are thinking like a web developer, you don't want to think about your users having to create a wallet, your user having to have a passphrase, your user having to pay gas. You want to be able to deploy something on the web very easily, and that is part of that. Part of that experience has to be that UX. Cross-chain bridging, again, you want that to come natively. There's applications across many chains. More importantly, there's liquidity across many chains. There are exchange integration around many chains. So by default, you can enable cross-chain operations without having to select a bridge, without having to have all this other infrastructure. Again, probability, and you can bridge with minimal trust assumption. You can support asset transfer across all major blockchain network, and you can unify liquidity. Again, I'm sorry if I keep repeating myself, but this says that education is just repeating yourself a lot. So I'll repeat it one more time. These are all functionality which are available. They're available across different websites, across different services. They're not bundled. We want to bundle it. We want to make it the environment that you have by default. It just comes with it. You don't have to go and get it. EVM aware. So I've mentioned before that we have created Etherlink. So Etherlink is a EVM compatible rollup built on top of Tezos. So if you can run your app on Ethereum, by and large, you can run it on Etherlink. Check it out. There's a bunch of applications. There's emerging DeFi ecosystem over there and gaming ecosystem. So the nice thing about it is that these are not two rollups. Let me get a bit into the specifics. So usually rollups, you think that they would communicate via the layer 1, and that's how you scale with rollups. You launch many rollups in parallel, and then they can make calls to each other via the layer 1. That's great, but unfortunately for optimistic rollups, that incurs a very high latency of communication inter rollups. You can do validity rollup, where you have much lower latency, but then you lose a lot of throughput. So instead, this runs in the same rollup as EVM. So you can think as Etherlink. So you can think of Etherlink and Jstz as basically running with the same node. The same node will process all transactions. What that gives you is instant composability between the two chains, so instant asset transfers at a minimum. Why does that matter? It matters for boring business reasons. Again, if you ever talk to an exchange and you have a custom infrastructure and you say, I have built this great chain, it's out of JavaScript, you will not believe it. The DevX is really impressive, and they will say that sounds great. Pay us $1 million for the technical integration in our exchange. And you're like, what? That doesn't cost $1 million. And it says, well, that's our pricing. So if you are EVM compatible, however, they will make it a lot less, because they do realize that it's hard to ask with a straight face to charge for changing a config file into a line in a config file. So if you want connectivity with exchanges, having an EVM bridge in some sense, or having a projection of your APIs into the EVM world is highly, highly desirable. And both environments benefit from Tezos L1 security and decentralization. It's all ultimately powered by the Tezos network. So when Jstz? Well, currently what's available now is a private testnet. It has an internal oracle. It doesn't run in a T, but again, this is just for testing. That lets you make HTTP calls and receive the HTTP calls in your contract to give you some sense. Calling another contract or calling a website is basically almost the same thing from the perspective of a smart contract. I like to joke, oftentimes you have developers come in into this ecosystem, and they say like, oh, can I just like, how do I make a web request from my contract? And you have to explain to them like, oh, that's not possible. How would that make sense? You know, it has to be replicated, it has to be verified. Does it make sense? And here we kind of flip this on the other side and say like, well, how do we make it make sense, right? Because if they want this, like, how do we make it that it makes sense? And you know, that's one way to do it. You can use existing ecosystem libraries from NPM and GSR. And then we have runtime API support through V8 and Dino. So Dino is an implementation of Node, which covers most of what you would want in Node. And again, compatibility with the latest ECMAScript specification and WinRTC, developer dashboard, all of that. I will give you a link at the end so you can go and try the private testnet for Jstz. Public testnet is coming probably around mid Q3. So maybe like a month and a half, 2 months, maybe 3 months if we're being optimistic. But it's coming. And it will set the experience for the Jstz mandate. So the medium-term state is going to, the state will reset, but we're going to try to make it as infrequently as possible. So don't put anything with real money on it, but at the same time, it's not going to reset every night. So you can actually have a bit of an experience. Maybe if you're doing a game, this type of things, it can even make sense to as a product. And it's going to be really about getting as much developer feedback. And so that comes with developer support. And then in exchange for this developer support, your developer, come here, we'll support you. In exchange, please tell us what you want to see in Jstz, how you want to see Jstz evolve, what features would be great for you, how do we make the best DevX possible in the entire industry. And then mainnet probably early next year. So we'll try to have a Web2-like user experience by account abstraction and all of the good stuff that I've been talking about, popular testing framework, etc. So that's coming, and it's a very different approach and a very different rollout from what happened with Etherlink. You know, what happened with Etherlink is maybe the only non-custodial L2. And I call an L2 custodial if there's a group of people with a signature that can control your assets. And then if you talk in Ethereum and say, oh, wait, but that's a level 23 rollup, it's different. Yes, they have the signature, but they can only do it if it's a bug. And I'm like, who determined that it's a bug? Well, they do. Okay, so you have a bunch of people with signatures who can take your assets, period. You know, like you can obfuscate it as much as you want. Etherlink launched as a non-custodial rollup. It made no compromises at all on decentralization. Very, very strong proposal, very much in the spirit of Tezos. We're experimenting with something a bit different with Jstz. It's really starting from developer first. And so I think it will be a more gradual rollout with a lot more interaction and user feedback before going to a fully decentralized product like Etherlink or like Tezos. How do you get involved? Experiment, explore, build. So you can check out the link to Jstz on Tezos.com. There's a QR code, but it's easy. It's just tezos.com/Jstz. You can join us on Discord. There's a community who's starting to play with Jstz. Again, here's the link to the Discord. All right, that's my presentation. We have maybe 2 minutes for very, very quick questions if anyone wants to raise. Yes, right here. What are the main challenges that Tezos have today? I think the challenge today for Tezos as an ecosystem is a challenge that most blockchains face, or even the entire industry face. It's lack of demand, lack of usage. Like we have some applications, we have a fantastic thriving art community. There's some great projects on Tezos. You can buy tokenized uranium. There's some cool DeFi application. We have on Etherlink, for example, an order book DEX. So there are some things, and I would say by the standard of other blockchains, there's actually quite a bit going on Tezos. But even when you look at some of the most used blockchains today, the ratio between the amount of investment and technology that's going on in the space compared to activity still leaves to be desired. And I think part of it has been a regulation issue. So for a long time, regulation has made it very difficult to do anything that was meaningful. So you've seen a lot of people just jump into whatever was, if you basically had no impact on the world as much as possible, you were more on the safe side. So we've seen the rise of meme coins. But now with evolving regulatory framework, we're seeing actually more things happening in stable coins. We're seeing things happening in prediction markets. So it's easing up a bit. And I think we're going to see more exciting application as regulatory framework finally stop waging a war on the industry. All right, that's all the time I have. Thank you so much for coming. Check out Jstz, tezos.com/JSTZ.